Okay, here we go. Oof, good morning. Glad to have you with me. We're going to speed up. Okay, I'm running out of time and patience doing these things. Like I want to clear the house here. Everybody's been following. Okay, let's just jump in. Precession. Very important event. Very important event. It's going to explain everything. Newton, of course, with his gravitas, tried to explain why things fall to the ground and how, calculus, along with Godfrey there, the German, came up with a computation system with, functions, mathematical explanation. Very good, very good. Now, we can say why cannonball falls to the ground. And of course, Haley asked Newton if he wanted a job, could he unite calculus with astronomy? He said, sure he could. He needed the job. Okay. And he came up with these formulations about, like he says, the apple falling. And he gave a name to it. And that's the greatness of Newton. Is wrong, but hey, you do a lot of things for a job. Just get the job first. And of course, the German guy, Godfrey Nibbersnatz, or whatever his name is, not German, or half relatives are German, but I can't pronounce German. But anyway, he didn't come up with that name, gravity, so we don't know his name. But he also came up with the binary system, which is the fundamental approach of why computers can work. And that's before we had computers. So what the hell, we all get short-changed here, short into the stick, so to speak. If you're not good looking, you're screwed. That's all there is to it in our system. But anyway, let's cut to the chase. With spinning objects, it's going to tell us one thing as we go down the line. It's going to tell us that everything starts as a binary. Okay, if it starts as a binary and we're trying to get a metaphor and an image, and of course Newton came up with the idea of gravity. You ever wonder about the word gravity, where it came from? Where did he come up with that word? Okay, well, let's do it the simple way. Gravitas. Okay, well, it kind of sounds like grave, doesn't it? Grave, gravity. Very grave stuff. Cannonball's going to hit you in the head if it falls. The moon, if it falls, is going to kill us all. Okay, maybe that's why he came up with the term. He really thought the moon was going to fall on him and kill everybody. So he came up with this term, gravitas, gravity, or grave. I don't know what the etymology of the word is, but anyway, that's the way it works. The gravity thing. But all of this is leading us, Newton, Godfrey there, Jeffrey, or whatever his name was, okay, in that matter has to have a starting point. It's linear. Everything's going to be linear. Chaos theory says that everything works crazy, but it's all based on a linear mathematics. We just haven't been able to figure out why math, being so linear, doesn't explain the universe, which is so chaotic. Well, we know now that it does. You just have to know the three laws to apply and how to use math, and then math will solve it all for us. Okay. How did it start? Well, I'm going to give you a model. You remember on Life how these two guys come up with the helix, and everybody just fell over backwards over this thing, and it makes a good model too. It looks great. Too bad Carl Sagan didn't have it. It would have looked good on his TV commercials. Okay. All matter does have structure, and that structure we're looking for. In life, of course, it's mitochondria. Life was formed all at once, just like all the elements. When the earth condensed, everything fell out. Well, everything fell out, gold, silver, all of the metals, most of the molecules, although you can make molecules going and coming, and water. And of course, as soon as water cooled a bit, within certain temperatures, life fell out. And it all fell out, and from this day on, it's a linear event, life, which covered the earth, and now we have limestone from one end of this earth to the other, basically, and limestone is a representation of life, the glue of those rocks. Is it from then on, it becomes a linear event down, counting down, and of course, many events take place molecularly. In mass, life starts with mitochondria and then breaks on down, but in mass, starts with the lowly clothespin. What's interesting, I'm going to show you a model. I have been working with models. Let's take this, the lowly clothespin. Well, if you look at it, and we think about mass being binary, that is, two parts make up an electron, and these parts are almost indestructible. You can't get them apart. They just stay together. And as you add a third part, it wants to shed it all the time and shuck it off. One part of our chaotic theory tells us, oh, it's coming down. Okay, I'm going to have to close off here. I only got about a minute and something. But I wanted to get this thing, which is very important. Those people in Norway who are watching my videos, this is the culmination of everything I'm talking about. Okay, visualize an electron as a clothespin. And if we visualize it and it can do what a clothespin can do, well, my God, look at what a clothespin can do. A binary unit with this event, that spring, of course, in our metaphor, is this precession that allows two objects in spin to unite and stay together. And then that spring is going to be an eventful event, and it's going to be able to allow two clothespins to go together, three clothespins to go together. Pretty soon you could make up a tremendous molecule with this approach. I call it the clothespin approach. Okay, I got to end it there, and we'll try and get this down, because I am getting I'm losing my interest in making these things. Okay, until next time, thank you.